So this is a review of the surface area and the volume section that we've done in this chapter. So what each of you have been given is a laminated formula sheet that looks like this, and the section that we're dealing with is all of this stuff here. So what I've done is I've put the formulas up on the Smart Notebook just so that I can go through them and show you what the formulas mean. So with the surface area of a prism, it has 2 times the area of the base. Remember when we named our prisms, we named them based on the shape of the base. So a triangular prism has a base that's a triangle. A hexagonal prism would have a base that's a hexagon. And then we have the lateral faces. In a prism, those lateral faces are rectangles. They might be the same size and shape, they might not be. So you have to be careful of whether or not you can multiply one rectangle by 4 sides or by 2 sides, or maybe you can't multiply it by any sides. Maybe it's just one rectangle and then another rectangle and then another rectangle. The surface area of a cylinder is 2 pi r squared, those are those circles, plus pi times diameter times h. Remember, this is the circumference and then times the height. The surface area of a cone is pi r squared plus pi rs. Remember, this is the slant height of the cone. So if I draw it, this is my cone. The s that we're talking about is this measurement right here. Okay, that differs from the height of the cone. This is the slant measurement of the cone. And then a sphere is 4 pi r squared, and that was the circle demonstration that we did with the oranges. The only one that I don't have listed on here that I just noticed is the surface area of a pyramid. So the surface area of a pyramid is kind of like a prism, only I have one base and then the lateral faces. So it shouldn't be that difficult for you to be able to calculate the surface area of a pyramid because, again, it's just calculating those different faces. Volume. If we are talking about the volume of a general prism, it's the area of the base times the height of the prism. So again, if it's a triangular prism, it's the area of that triangle times the height, or sometimes it's the depth of the prism, depending how it's shaped. A rectangular prism becomes length times width times height. So a Kleenex box, length times width times height gives me the volume of that pyramid, or of that Kleenex box. The volume of a cylinder, pi r squared times h. This is still the area of the base times the height. The cylinder's base is a circle, pi r squared times height. When we get into pyramids and cones, the pyramid we relate to the base, to the prism, area of the base times the height, and then we divide the answer by 3. If you remember, that was the demonstration that we had pouring the water. The cone, the area volume of a cylinder, divided by 3. So it's 1/3 the volume of a cylinder. A pyramid is 1/3 the volume of the prism. And then the sphere that we have was 4/3 pi r cubed. So it's related to a cylinder. So those are your formulas. What I want you to work on in this section is to practice your skills in your textbook. Starts on page 160. All of the questions. Watch the units, pay attention to what you have to be converting to. Things to remember, 1 cubic centimeter equals 1 milliliter. So remember that calculation, so that if you're doing capacity and you need to transfer into milliliters or into cubic centimeters, you're able to do so. So it's a very short lesson. Now you can work on the questions with the time that you have remaining, and we will see you in the next class.